Maadjong buntag sa inyong tanan. Welcome to my channel. Our topic for today, inverse trigonometric function formulas. To start with, inverse trigonometric function formulas, by integrating the differential of the inverse trigonometric function, the following formula was derived. We have integral of du all over square root of e squared minus u squared is equal to arc sine u over a plus c. So this is our number 16 formula. ITF number 16 stands for inverse trigonometric formula number 16. Our second formula for inverse trigonometric function formula, integral of du a all over a squared minus u squared is equal to 1 over a arctan u over a plus c. So this is our second formula for ITF. Called it ITF number 17. It's always a wise thing to do if we have mnemonics for our formula. For example, ITF number 16 it stands for inverse trigonometric function formula number 16. So we can easily recall such formula if we are evaluating and discussing certain inverse trigonometric function problems. Okay, let's proceed to our sample problem. Our sample problem, example number 33, can be found in your workbook on page 59. Evaluate the integral of dy all over square root of 4 minus 9y squared. So for our solution, again, we need to simplify certain function first. So for numerator, no need. So for denominator, we'll focus on square root of 4 minus 9y squared. Or we can simplify this or expound into 9 square root of 4 over 9 minus y squared. If we're going to distribute 9 inside the radical, we cancel 9 and we have 9y, and we're going back to its original form. Okay, so our function integral of dy square root of 4 minus 9y squared can be rewritten as dy all over 9 square root of 4 over 9 minus y squared. So by this form, we can use our property number 2. So we need to carry out a real number constant. So in this function, we carry out 1. This is square root of 9 since this is both inside the radical. So we carry out our 1 over square root of 9 real number constant integral of dy over square root of 4 over 9 minus y squared. Okay, our next thing to do is we need to reduce the fraction. For our 4 over 9, if we have 4 over 9, this is also equal to 2 squared over 3 squared. Square root of 2, 4, square root of 3, 9. And property of our exponent. So we can write this into 2/3 squared. Okay, going back to our function, we square root the 9. So that is 1 over 3. Integral of dy all over square root of 2/3 squared minus y squared. Okay, so if we're going to evaluate our function, they are all aligned, all in y, and this is stands for our a constant and this is for our u. If we're going to check again, our function is aligned, so we can use and apply our inverse trigonometric formula number 16. What is the formula? Integral of du square root of a squared minus u squared is equal to arc sine u over a plus c. Okay, so we apply our formula. Okay, 1/3 arc sine, what is our u? That is our y. What is our u? Y squared. What is our a? 2/3 plus c. Going to rationalize our fraction. Our final answer is 1/3 arc sine 3y squared over 2 plus c. Okay, that is your final answer for your example number 33. Wait, I think we have a correction. AU, we only need to write the y. Okay, final answer 1/3 arc sine 3y over 2 plus c. Okay, so let's move to our next example. Our example number 34 can be found in your workbook on page 60. Okay, example number 34, evaluate the integral of dz all over z squared plus 6z plus 10. Okay, so for our solution, dz z squared plus 6z plus 10. We need to simplify our polynomial, the denominator. Since we have nothing to do with our numerator, it's okay. So for our z squared plus 6z plus 10, this is also written as plus 6z plus 9 plus 1, so that we can factor out this x squared plus 6z plus 9. So using our expansion formula, a squared plus 2ab plus b is equal to a plus b squared. So our factor for this polynomial is z plus 3 squared. So if you're going to check, z squared plus 2, our a is z, b is 3 plus 3 squared. So z squared plus 6z plus 9. So they are the same. So we need to apply this one. But don't forget our 1, okay? So we can write it as your z plus 3 squared plus 1. We still have 1, di ba? Okay, so we're going to write our function, rewrite our function. And we align it according to the arrangement of the ITF formula. So a squared plus u squared. Okay, so integral of dz, so we need to align real number constant first. So our 1 plus quantity z plus 3 squared. Any number 1 raised to any power is still the same. So 1 squared is still 1. So if we are going to evaluate our formula, we can say that we can apply our ITF number 17. But we need to replace our DC with our U. So we still have to determine the correction factor. Our property number 3. If we're going to determine our correction factor, so if we let our U equal to z plus 3, we can say that our first derivative of our U z plus 3 is 1. Therefore, our d z is equal to 1 over the reciprocal of your du. Okay, so your dz 1 over 1 du, which is equal to du only. So we apply our correction factor. So we write it here. So applying our correction factor, our dc, we replace it with du. So now no multiplier. It's only 1. So for our au, that is our 1 squared. Then we replace our z plus 3 with u squared. So it is obvious that our function is ready for integration. Now we can apply our inverse trigonometric formula number 17. What is our ITF number 17? That is du au squared plus u squared is equal to 1 over a arc tan u over a plus c. So we can apply our ITF number 17 formula. So 1 over a, our a is 1, still 1. So arc tan u over a, which is 1, plus c. And we can recall our u is equal to z plus 3. So we rationalize. We can no need to write 1, that is arctan. Our u, that is z plus 3. No need to write 1, it's z plus, you can write it z plus 3 right away. Any number divide by 1 is still the same. So that is z plus 3 plus z. So that is your final answer for our example number 34. Okay, moving on to our next sample, example number 35. Your example number 35 can be found in your workbook on page 61. So the problem, example number 35, we need to evaluate our sine theta d theta all over 7 plus cosine squared theta. Okay. If we're going to evaluate our function, the denominator is already aligned, except that we need some modification of its details, the 7 and the cosine squared theta. Okay, we can say, let's start with 7. 7 is also equal to your quantity square root of 7 squared. If you apply the power, you only cancel out your, so this is still 7. So we can say that we can use this as our a. Going to your denominator cosine squared theta, as you can recall, you can rewrite also cosine squared theta to quantity cosine theta squared. So it's obvious that we can declare this also as our u, but we have still sine theta at the numerator side. Okay, for that, if we differentiate cosine, we can get sine. So we can eliminate sine theta. So by applying our property number 3, the correction factor, if we let our u equal to our cosine theta, we can have the first derivative of your cosine is negative sine theta. Therefore, our d theta is equal to the reciprocal of your first derivative du. So that is your 1 over negative sine theta du. Okay, so we can apply our correction factor, but before that, we need to rewrite our function according to the alignment of ITF formula. So our sine theta d theta 7 plus cosine squared theta is also equal to sine theta d theta all over square root, should say square root of 7 squared plus our cosine theta squared. So we have our a and we have our u, but already determined our correction factor, so we can apply our correction factor to our function. Sine theta, so our d theta, we replace it with our correction factor, that is 1 over negative sine theta du all over square root of 7 squared plus cosine theta squared. So we do some cancellation. Cancel out sine theta, cancel out sine theta. The remaining is negative. Okay. So we apply our property number 2. Carry out the real number constant out of the integrand. So we have still negative. So negative integral of the remaining is only du all over square root of 7 squared plus cosine theta. We replace it with our u. That is our u. U squared. Okay, so our function is ready for integration. So we can apply our ITF number 17 formula. What is your formula? So integral of du au squared plus u squared is equal to 1 over a arc tan u over a plus c. Okay, apply. Negative 1 over a. That is our square root of 7. Arc tan our u over square root of 7 plus c. So finally, we can recall our u, which is cosine theta. Okay, so rewrite our answer. So negative 1 over square root of 7 arc tan u cosine theta all over square root of 7 plus c. So that is your final answer. Okay, moving on to our next example. Example number 36. Example number 36 can be found in your workbook on page 61. Okay, the problem is example number 36. Evaluate the integral of quantity 3x minus 4 all over x squared plus 2x plus 17. Okay, the same procedure like what we did on problem number 35. We need to simplify each term, the numerator and the denominator. Okay, we start with the numerator. We can say that 3x is also equal to, if we're going to factor negative 4, we can write it as 3x plus 3 minus 7. So 3 minus 7 is negative 4. For 3x plus 3, we can still factor this out. We carry out 3. So we can 3 quantity x plus 1 minus 7. Okay, so we have our numerator. Then our solution. So quantity 3x minus 4 all over x squared plus 2x plus 17 can be written also, can be rewritten to our simplified numerator. Integral 3 quantity x plus 1 minus 7 all over rx squared plus 2x plus 17. Okay, we distribute our denominator to our numerator. Since our numerator, the subject of our numerator can be considered into two terms. Okay, so we separate them. Okay, we still have our dx here. So dx dx. So we separate our terms. So we can rewrite this to integral 3x plus 1 all over x squared plus 2x plus 17 dx. Then our 7 minus, maybe we can carry out 7 already as your positive real number. So our dx, we write our dx here over x squared plus 2x plus 17. Okay, we only distribute our denominator to our numerator. Then applying our property number 2 here, carry out real number constant to the other side of the integrand. The other one naman is we distribute our property number. We use here property number 1 and property number 2. Okay. Also, maybe we can apply power formula here, our property number 2 for easy evaluation. We just move the 3 as a real number constant. Okay, so we have two integrals. So we need to integrate each subject. So we'll start here first. We'll start this dx first. So we need to utilize our space. Okay. So for 3x plus 1 x squared plus 2x plus 17. So we determine our correction factor here. So we let applying our property number 3, our correction factor CF, we let RU equal to its denominator, which is that is your x squared plus 2x plus 17. If we get our first derivative of our denominator, we get 2x plus 2. So we can apply our dx is equal to the reciprocal of your first derivative of your constant du. So we can rewrite 1 over 2x plus 2 du. And also we can factor out 2 here. So finally our dx is equal to 1 over 2 quantity x plus 1 du. So we have our dx. So we can apply our dx to our function. So applying our dx to our function, 3x plus 1, our dx 1 over 2 x plus 1 du all over, we replace our denominator by our u. Okay, so doing some cancellation. X plus 1 cancel, x plus 1 cancel. So the remaining is 1 half. Then we apply property number 2. We carry out the 1 half outside the integrand. So it becomes 3 halves. Integral of the remaining du over u. Here, we carry out this 1 half. So that's why it becomes 3 halves. So we can apply our power formula. Power formula or our logarithmic formula number 3. We have du over u, that is your ln absolute u plus c. So we apply. So 3 halves ln of u plus c. Then we recall our u. Recall u. So we rewrite 3 halves ln absolute of x squared plus 2x plus 17 plus c. Okay, we are done with our first subject. Moving on to our second subject. Okay, so equal to negative 7 integral of dx all over x squared plus 2x plus 17. In this side, we need to factor out first our x squared 2x plus 17. So we can rewrite x squared plus 2x plus 17 to x squared plus 2x plus 1 plus 16. So we can factor out x squared 2x plus 1 using our expansion formula plus 2ab plus b squared, which is equal to a plus b squared. So we can have our x plus 1 squared plus 16. To check if our factor is correct, so x squared plus 2, our x, a, our b is 1, our b is still 1 squared. So x squared plus 2x plus 1. So the same. So we have a factor x plus 1. We have a factor x plus 1 squared plus 16. So we use this as our denominator. Okay, so negative 7 integral of dx. So we rewrite our polynomial in line with the ITF formula. So this is 16. You only rewrite, you only rearrange. Plus x plus 1 squared. We all know naman that our 16, 4 squared is 16. So we replace our 16 with 4 squared. So our function is aligned with our ITF formula. Okay. So negative 7 integral of dx 4 squared plus quantity x plus 1 squared. So we can use our ITF formula number 17. But before that, we still have x. So we still need to determine our correction factor, or property number 3. But it is obvious that if we're going to determine our correction factor, if RU is x plus 1, our first derivative is only 1. Therefore, our dx is equal to du. Okay, so we just replace our function with appropriate symbol. So the du over 4 squared plus u squared. So here, we can apply our use and apply our ITF number 17. What is our ITF 17? That's integral of du over a squared plus u squared 1 over a arc tan u over a plus c. So we're going to apply our ITF number 17 to our function. So negative 7, 1 over a, 1 over 4 arc tan u over a, or 4 plus c. Then we recall our u. We all know that our u is x plus 1. So we rewrite negative fraction 7 over 4 arctan x plus 1 over 4 plus c. Then we combine our number 2 and number 1. We rewrite it to make our final answer. So 3 halves, we combine all the constant also. Ln of x squared plus 2x plus 17. So minus 7 over 4 arctan x plus 1 over 4, the combination of two arbitrary constant, plus c. So that is your final answer for problem number 36, example number 36, final answer. Okay, let's move to our last example. Example number 37. Example number 37 can be found in your workbook on page 62. So we need to evaluate the integral of x dx all over square root of 1 minus 4x x squared. So as you can see, the arrangement of our denominator inside the radical, the last term is our x squared. So we need to rearrange it or rewrite it to the normal form, starting with the power x squared. But before that, the confusing part is x dx. We still need to expand our x. How? If we're going to expand this x, we can rewrite it also into, if we're going to write 2 plus x minus 2, this is equal to x. Same procedure we did in example number 36. We break out the numerator. So we're going to use this one. Quantity 2 plus x minus 2, which is still equal to your value of x. And for your denominator inside the radical, so we need to rewrite. Okay, so 1 minus 4x minus x squared. So we need to expand. We need to factor out this 1 minus 4x x squared. So we can say that 5 minus 4 is equal to 1 minus 4x x squared. Okay, so we can factor out negative 4 minus 4x minus x squared, which is equal to your on quantity x plus 2 squared. How? We're going to use our, by doing this, you will arrive with this factor form. A x squared 2 x, our b is 2, then our b is 2 squared. So x squared plus 4x plus 4. So they're the same. So the negative. So we're going to use our expanded form, this one, and our factor out form to our equation or to our function. Finally, our integral of x dx over the square root of 1 minus 4x x squared can be rewritten into quantity 2 plus x minus 2 dx, but later then our square root of 5 minus x plus 2 squared, so dx. Okay, same procedure with problem 36. We distribute and we break our subject, the numerator, into two subject. Property number, we distribute and break property 1, and so we still have 2, we still use property 2. Doing so, rewrite this one, applying our property number 1, 2 plus x dx all over square root of 5 quantity squared, x plus 2 squared, minus, so we have 2 as our real number constant. Applying property number 2, we carry outside of it engram, and the remaining is dx square root of 5 quantity x plus 2 squared. Okay, what else we need to do? We solve it separately. We focus on our subject 1. Start here muna. 1, and this is our 2. Start here with 1. Okay, we can eliminate our radicals at our denominator. We can rewrite our subject number 1 to 2x 2 plus x dx all over, we remove the radical, 5 minus quantity x plus 2 squared raised to 1/2. Then we remove the fraction also. By removing the fraction, will become quantity 5 minus x plus 2 squared raised to negative 1/2 is from denominator going up to remove the fraction form, so that's negative 1/2. So in this side we still have 2 plus x dx. Here we can use our power formula. But before we can use our power formula, we need to determine our u, which is our u is this one. So we apply our property number 3. Determine the correction factor. So our u, correction factor CF, is 5 minus x plus 2 squared. So doing the first derivative, the remaining is negative 2x before distribute negative 4. Negative 2x minus 4. Okay, so our dx is equal to the first derivative of du, that is dx is 1 over negative 2x minus 4. But we can still rewrite this du. So dx is also equal to, we carry out 2, negative 2x minus 2. Negative times negative positive, so that is positive 2. Du. Okay, so we can apply our correction factor to our function. Integral 5 minus quantity x plus, we replace this with our u already because we get the derivative of that term. So that become our u, including the power, raised to negative 1/2. The remaining is 2 plus x. Then we can replace it with our correction factor dx now. That is 1 all over negative 2 quantity x plus 2 du. Okay, we can cancel out the x plus 2. The remaining is negative 1/2. Moving out the negative property number 2, that is negative 1/2. The integral of u, negative 1 raised to negative u 1/2 du. It's obvious that we can apply our power formula. If you're going to apply your power formula here, your answer is using our power formula. We lack of space already. Consuming, still need to show it. Maybe we can have our next page na lang. First, we'll focus on our first subject here. So the remaining is negative 1/2 integral of u 1/2 du. So we apply our power formula. So negative 1/2 quantity, our power formula, u negative 1/2 plus 1 all over negative 1/2 plus 1. D plus C to become 1/2, will become 1/2 U 1/2 plus C. So we carry out 2 going up. Final answer is negative 2 over U 1/2. So over 1, cancel both sides. Cancel 1, cancel 2. The remaining is U 1/2 plus C. Okay. Okay, but we still need to recall our value for our U. So our U raised to 1/2 plus C. What is our U? Our U is here. Just need to apply 5x plus 2 squared plus C. This is to power of 1/2. Maybe we recall back its original form to its radical form to make it simple. So 5 minus quantity x plus 2 squared plus C. So this is your answer for your first subject. Oops, we still have negative here. Look, still have negative. Okay, I think we need to move to our next page. So rewriting our answer is negative 5 minus x plus 2 squared plus C. So that is negative square root of 5 minus x plus 2 squared plus C. So this is our first subject. How about for our second subject? We still need to solve this one. So that is your negative 2 dx squared of 5. Okay. So we still need to solve our 2 minus 2 integral of dx all over square root of 5 minus quantity x plus 2 squared. Okay. Actually, we have nothing to do with here with this our second subject. Just need to rationalize our 5. Same with our example number 36. 5 can be rewritten to quantity square root of 5 squared. But that's still 5. If you're going to apply square root square, that's still 5. Square negative 2 dx. Or if we're going to apply, that is square root of quantity square root of 5 squared minus x plus 2 squared. So we can say that this is our A and this is our U. We can apply our ITF, inverse trigonometric function, formula number 16. So that is du over square root of AU minus u squared is equal to arc sine u over a plus c. We apply it right away since No need to determine our correction factor, since if RU is x plus 2, if we're going to get the derivative, we only get, if we're going to apply property number 3, our correction factor determination, our dx is only also equal to your du. So we simply rewrite it to be clear. So our dx is equal to du square root of quantity square root of 5 squared minus, we replace it with u squared. So they are aligned and ready for integration. So negative 2 arc sine, what is our u, over our a square root of 5 plus c. Again, our u is x plus 2. Recall our u, 2 arc sine x plus 2 all over square root of 5 plus c. We combine our two subjects to get our final answer. So moving to our final answer, negative square root of 5 minus x plus 2 squared plus c minus negative 2 arc sine x plus 2 over x square root of 5 plus c. We combine all the arbitrary constant, and this is your final answer. We just combine to the two arbitrary constant. So that is already your final answer. Okay? Or you can still rewrite this one. You can still rewrite it, going back to its original form. As you can recall, our 5 minus x plus 2 squared is equal to your 1 minus 4x minus x squared. So we can still do that. So that is minus square root of our original form, 1 minus 4x minus x squared minus 2 arc sine x plus 2 square root of 5 plus our c, our arbitrary constant. Okay? So that is your final answer for example number 37. For students, you can submit your exercise number 5 to your model account using standard exercise form in submitting your final answer and your solution. So that's all for today. Thank you everyone and have a nice day. God bless you all.